Hi guys, my name is Chris and welcome to the fifth video of my series Z80 with Bread, in which I'm trying to build a Z80 based computer on a breadboard. Today, I would like to show you my DIY TXMO GPU, so let's get started. Since the last video, I've added some things to the computer, and one big addition is this chip, which is an Atmega 328, and its function is to generate composite video signals. And to generate them, I'm using the Arduino TV Out library. Anyway, if I power on the computer, we can see the hold LED go off, and now we should see the text on the TV. And here is the text. So now I will show you the code for the computer and the GPU. So see you in VS Code. Here we are in VS Code, and this is the code for the computer. This code is just the modified version of the code that I have had in the previous video. So I will only explain the modifications and additions that I did. Right away we can see some new things that have been added, like this GPU fill command, which is assigned the value of hex 12. This is just a command on the GPU that fills the screen with the specified color. And I will show you the other commands once we get to the GPU code. Here we have the definitions for some characters like the character drone, line feed and the null character, and here we have the definition for the black color. Here in the code you can see that I've initialized the stack pointer to point to the top of the RAM, otherwise we won't be able to use the RAM. And if I scroll down, you can see some new labels and some new instructions like this call. So this test display just tests the display and it outputs the character to the screen. And it calls the clear display routine, and the clear display just loads the GPU fill command to A, and it calls the write character subroutine. And the write character is right here. It outputs the character in register A to the CIO because the GPU is connected via serial line, so to use it we use the CIO. So once we output the character, we call this wait for TX empty, and it is right here, and it waits for the TX buffer to be all sent, and it does that by selecting the read register on the CIO, and the bit 0 of the read register is called all sent, and when it is 1 it means that the character has been sent. So once this returns, this write character returns, and it goes to this line. This loads the black color to the A and outputs the black to the GPU. And we don't need the null byte because black is defined as hex 0, as you can see here. Now this clear display returns, and we call this word delay. This is just some delay to not overwhelm the GPU with the serial data. Here is the text part. We load the initializing text, which you can see here at the bottom. This is just label, and in the label is define bytes, and in the define bytes here is the string init complete, and here is the null byte because this normally doesn't have a null byte at the end. We need to add it manually. So we load the initializing text to the BC register and call write string, and the write string loads the character, the first character from the BC, you can see here, and it compares that character to the null byte. So if it is null byte, it just jumps to the end and it outputs the character turn, line feed and the null character, because it stopped at the null byte and it doesn't include it. So we need to add it manually, and we call the word delay. When the character is not a null byte, we call the write character and we write the character to the GPU. Then we increment the BC, so we get to the next character and jump back to the loop. So this repeats until we get to the null byte, which you can see here. And this is the same as this, but this is just the hello world string. So now for the GPU. This is the GPU part. You can see that I use the TV out library. Here are some defines, and here are some commands. The GPU has a set cursor command, a set pixel command, and a fill screen command. And the commands you can see here. This is the fill screen. This is the hex 12 you can see in the computer. And the format is this, not this. I forgot to change this. So we send the hex 12. Next we send the color, and lastly we send the null byte. For the set pixel we send the command, then the XY coordinates, the character, and the null byte. And for the cursor we just send the command, XY, and the null byte. I will save this file, and the fill screen just gets the data from the serial. You can see here, this is the setup. We begin at the baud rate, and the baud rate is 3884, which we used in the previous video to communicate with the computer. We begin the TV out library. I'm in Europe, so I use PAL, and the max resolution that this library supports is 128 by 96. Then I select the font. Font is 6 by 8, and in the loop I just wait for the serial, and then I read from the serial input until I get the null byte. Then I echo back the data, check if the data is less than 2, and if it is less than 2 I return, and if it is normal I just call this method handle data, and this is the function that I've showed you. This just checks the first character, and if it matches some commands like the set cursor, set pixel, or the fill screen, it performs this action in the brackets. Otherwise, if it does not match, it just prints the character to the screen. And that is pretty much it. And I forgot to mention that all the source codes are available on my GitHub page, which is linked in the description. So if you want to check this code or any code that I've showcased in the videos, if you want to check it out more closely, you can find it on my GitHub. So that's all for today's video. I hope you liked it, and I'll see you in the next video. So bye.